All right, so we're going to look at what's called the vector product or the cross product. So the cross product gives a vector perpendicular to two input vectors with magnitude equal to the area that they span. So let's have a look at some vectors in three-dimensional space. We're actually in the 3D viewer here, so this is 3 dimensions. And what we're going to do is we're going to put some vectors in. So let me show you. Let's put some vector in. We're going to call that vector A. And then we're going to put some other vector, vector B. Now you would agree that the angle between them is represented by this point here. And just to sort of show you that we're in 3 dimensions here, you can sort of got the angle between A and B shown there. Okay, then what we're going to do is we're going to draw a perpendicular from the endpoint of B such that it sort of projects onto vector A. So we've got this perpendicular line here, and then we've got this vector, we've got this angle in here, which is 90 degrees. Okay, what we're doing now is we're going to take that and we're going to find the vector that's perpendicular to those two vectors. So you can see that they sort of sit on this x-axis. And so the perpendicular vector would be kind of pointing out at you, right? So in sort of 3 dimensions, you can see that the cross product of A and B is this vector that's sort of pointing out at the page for us here. Okay, and what we say is the size of this vector is equal to the area of the parallelogram that is spanned by the vectors A and B. So you're probably wondering what on earth that means. But if you made a parallelogram, you got B, if you take this length here to be A, and then you have B again over here, you would get a parallelogram. And the area of that parallelogram is the magnitude of the cross product. And the cross product, the direction of the cross product is always perpendicular to the two vectors that you have. So let's talk about that in a bit more detail and sort of see what's going on. We're going to represent this in 2 dimensions, but you have to think in 3 dimensions. So we've got vector A here. We've got vector B here as well. So we've got 2 vectors, and you would agree that they sit on some sort of plane in space. The first thing we can say is that there is an angle between them, and we know that the cross product is perpendicular to both of those vectors. So what you have is a situation where A cross B is perpendicular to both vectors A and B. Okay, and then what we're going to do is we're going to talk about the size. So the size of A cross B is equal to the magnitude or the absolute value of A cross B, and that's equal to the area of this parallelogram. So let's see if we can work that out. The first thing we can say is we're going to work out the height of the parallelogram. So the height of the parallelogram, well, we're just going to use some trig ratios. We know that sine, remember SOHCAHTOA, sine equals opposite over hypotenuse. So for our triangle here, if we want to know the height, the opposite side is this here, which we're going to call h. So this part here is h over the magnitude of b. Now this length here is the magnitude of b. So if we rearrange this for h, we can get the height of this line here, which is the height of our parallelogram. So rearranging for h, we get the magnitude of b equals sine theta. So that must be this height here. So that's the height of our parallelogram. And to find the area of a parallelogram, you multiply the height by the width. Well, I think you would agree the width of this parallelogram, or the base length, shall we say, is the magnitude of vector A, however big vector A is. So we get that the magnitude of the cross product is equal to the magnitude of A, vector A, multiplied by the magnitude of B, multiplied by sine of the angle between the two vectors. And that's really it. We know the direction. The direction is perpendicular to both the vectors, and the size of it is equal to the area of the parallelogram that's created. We would say is equal to the area of the area spanned by the vectors A and B. And you're probably wondering why on earth do we need to know this? But it has lots of interesting applications in physics and engineering when you need to calculate the cross product between two, say, forces, which could be represented by vectors in space. So hopefully you found that interesting, and good luck with all your studies. I'll see you soon.